What is electric flux? Suppose we explain like this. Suppose we have a surface. This is surface. Number of field lines. We discussed what is field lines. Who is responsible for field lines? A charge, a stationary charge. A stationary charge creates electric field as well as magnetic field, both. We are talking about only electric field. Suppose I put a charge on this surface here. What will it create? It will create electric field. Electric field lines will diverge in all the directions if it is positive charge. Negative means towards it. Now suppose I am keeping the charge not on the plane but here, up distance r away from this point. So what will happen? All the field lines will diverge out, but few field lines will pass through this surface perpendicularly. So whatever number of field lines will pass through this surface perpendicularly, those field lines are called electric flux. That's it. The funda clear? So electric flux is a term which is related to field lines, but all those field lines which are perpendicular to the surface. So you can write down the definition. What is electric flux? It is the number of field lines passing through a surface perpendicularly. Passing through a surface perpendicularly. That is your electric flux. Noted? Okay. Now all of you see here. If you see this page is what? Surface. So whatever I'm able to touch is basically called what? Surface area. Now there are two things. Area and area vector. Both are two different things. They are not same. If this is area, area vector will be something which is perpendicular to it. So read the questions carefully whether they are telling the plane. So this plane is the area. But if I ask you what is area vector is a vector which is perpendicular to this page and coming outwards. Perpendicular and outwards, not inwards. Perpendicular and outwards. That is called area vector. So make a note of the term area vector. So it is perpendicular to the surface area, or you can say plane, anything. So how do we denote electric flux? Electric flux is denoted by phi E. Phi is the symbol for flux. E means electric. So if I want to write magnetic flux, I will write phi. So the formula is E dot delta S. So flux, which is electric flux, is dot product of electric field with area vector. What is the direction of area vector? Perpendicular to the surface, not along the surface. Direction of area vector is perpendicular to the area, or perpendicular to the surface area, or perpendicular to the plane. So if you see the formula, it is basically dot product, or you can say scalar product. So electric flux will be a scalar quantity or vector? Scalar. Scalar quantity. It is scalar quantity. Now, can you tell me the SI unit by seeing the formula? Electric field is what? What is the SI unit of? Newton per Coulomb.
Coulomb.
What is surface area? Meter square. So what will be the SI unit? Newton meter square per coulomb. Find the dimensional formula, all of you. Calculate the dimensional formula for electric flux. Electric field, you know, area is what? L square. Find the dimensional formula for electric flux. Find the dimensional formula for electric flux quickly. The answer. Quick. Calculating. Time. What is the answer? 1 second. ML cube T minus 3. Then T minus 1. Aditya, what is the answer? Same. You got? Surya, Tanvi? Same answer. Shubham, still solving. Same. This question is asked in the exam. Okay, to remember the answer. Anyone who didn't get, remember the answer. This question is in the exam also. Obviously. What are you thinking? Board exam. Okay, anyone who is stuck can see on the board. We know that electric field is what? Force by charge. So force is M1 L1 T to the power minus 2. What is charge? 80. Correct? So electric field will be how much? M1 L1 T to the power minus 3 A to the power minus 1 multiplied by surface area or area. Area is what? L square. This is area. So M1 L cube T to the power minus 3 A to the power minus 1. This is the dimensional formula for electric flux. If you check your NCRT, in the end of the chapter, there is a blue box. If you haven't yet, you can check now, or after the class, you check. After every chapter, in the end, you will see a blue box in which formulas, summary, and you will see all the dimensional formulas written. So after every chapter, you make sure that you draw that table in your notes. And those dimensional formula, you don't have to remember. You need to know how to derive them. You can't remember because after every chapter, the table is there. So how many will you remember? You need to know how to derive them. Okay, so make this a practice. So electric flux का definition is clear. Scalar quantity, SI unit, dimensional formula, area vector. Area vector is not same as area. Area vector is perpendicular to the area. Why I am repeating this? Because the numericals, what we are going to do, in that this mistake happens. Angle, what will be mentioned in the question, will be mentioned with respect to the area. But here, when you take the dot product, what is A dot B? AB cos theta. So the theta is not the angle between electric field and area. Theta is the angle between electric field and area vector. Okay, so be careful. Huh. Electric flux is not coming. You think that I'll give the question which is coming in the exam? Why will I give that? If I give also, I should not tell, obviously. Electric flux is not coming till electric dipole. Okay, only whatever we finished yesterday will come. Other than that, nothing I'm asking. If I ask also, that will be a bonus question. You'll get full marks for that. Okay, so this E dot S can be written as E delta S cos theta. Okay, you guys know that A dot B is AB cos theta. And theta is the angle between electric field vector and area vector. Theta is the angle between electric field vector, area vector. I'm repeating again. Theta is not the angle between electric field and area. It is the angle between electric field and area vector. Any questions? Remove it. Copied everything. We'll finish this chapter in the next class. This chapter will get over. What is left after electric flux? Only one thing is left, which is Gauss law. Okay. So I will not teach Gauss law today. I will just finish flux, and after that we'll start solving questions. Gauss law I'm keeping for the next class. Okay. Now, suppose electric flux, not electric flux, electric field is not uniform. It is variable, and I want to find the flux. So whenever a particular parameter is variable, which mathematical tool do we use? Integration. Okay. In grade 11 also I have discussed this multiple times. When you see that things are working on an average or constant or uniform, we don't use integration. But the moment things are changing and you want to find the total, we use always integration, because the meaning of integration is only total. Integrate everything. So what will be the total flux? Total electric flux. If electric field is variable, then we write integration of E dot ds. If you are getting confused with ds, you can write dA. Anyone who is getting confused that, sir, ds means displacement, I am writing this as a surface area. So if you are getting confused, instead of s you can write a also. It's totally fine. So you decide. If you're getting confused, you write dA. Both are correct. So when will you apply this formula? When electric field is not uniform, or you can say when electric field is variable. If electric field is constant, you just do the dot product. If electric field is constant, just do the dot product. If electric field is variable, do the integration. If you remember work power energy, same thing we discussed in work power energy also. If force is constant, we used to do F dot displacement. If force is variable, we used to do integration F dot ds. So there ds was not area or surface area. There ds was displacement. Here ds is not displacement. Ds is surface area, small surface area. That is the reason I told that if any confusion is with you, you write this S as A. But don't start thinking that that is displacement. All clear? Sure, let's start solving numericals. So all of you remember dot product? If anyone has doubt in solving dot product, you can ask. I will explain everything. I have told already. Any basic problem you have, you can ask. No need to hesitate in the class. We'll discuss everything. The first question. First numerical is if electric field is 6 I cap plus 3J cap plus 4K cap, calculate the electric flux through a surface area of 20 units in YZ plane. This is the question. So electric field is in which plane? See the vector? 3D plane. I, J, K. All three components are there. This room is which plane? 3D plane. Means electric field is present in the space of this room. We call this as space. Surface area. Area is in which plane? YZ.
2D plane.
2D plane. Which plane? YZ. So surface area is YZ. Area vector will be in which direction? X. What is perpendicular to YZ? X. Okay. So the data will be given in this form. You need to identify. That's why I was repeating that statement again and again. Area vector should be always perpendicular to the surface area. So surface area is YZ. Area should be perpendicular to YZ. So the direction which is perpendicular to Y and Z both is what? So let's write down. Do write down Y area vector is 20 I cap. X direction 20 I cap because it should be perpendicular to YZ. Electric field is variable or constant? Constant. So should we use integration? No. Dot product. So 6 I cap plus 3j cap plus 4k cap dot 20 I cap. I'm repeating again, area vector. This is area vector. Area vector is perpendicular to the surface area. Surface area is in YZ. So perpendicular to YZ is X direction, which is I. Do make a note of the reason. So let's do the dot product. What is the answer? 120. Electric flux, Newton meter square per. Any problem in dot product? Anyone? See, in dot product, I will tell you simple thing. Multiply the similar components. So which is the similar component? I. 20 into 6. Any j component? Answer will be any k component. In dot product, rule is simple. I with I, j with j, k with k, none. There is no j and k here, so that's why the jk answer will be 0. And any doubts? Anything? Okay, next problem. So the next question is a circular plane sheet. A circular plane sheet of radius 10 centimeter is placed in a uniform electric field of 5 into 10 to the power 5 Newton per coulomb, making an angle of 60-degree with the field. Calculate the electric flux through the sheet. Circular plane sheet of radius 10 centimeter is placed in a uniform electric field, making an angle of 60-degree with the field. So the angle 60-degree is formed with the circular sheet, correct? So 60-degree is the angle with the area vector or surface area? Surface area. We read the question. So the angle between the electric field and surface area is 60. What should be the angle between the electric field and area vector? 90 minus 60. If this is still not clear, See on the board, I will explain through a figure. It should be clear, but this is the sheet. Where is the area vector? Perpendicular to it. Area vector is perpendicular. This is your area vector. Area vector, or you can say, now the electric field is making, this is electric field line. Electric field line is making 60 degree with the plane. With the plane. How much angle this will make with area vector? 30. 90 minus 60. So when you solve the question, you will take theta is 60 or 30 here? 30. Any doubt, anyone? So now solve the equation. Tell me the answer. Answer will be what?
Sir,
S
15700.
PS cos theta. Okay, I'll check, Tanishka. I'll check. So
Yes.
it will be what? E into area into cos theta. So what type of sheet this is? Circular. So area will be pi r square. Calculate. Electric field, area, and then cos 30. What's the answer? Tanishka, what is the answer you told?
Sir, it would be 1.35 into 10 to the power of 4.
Yeah, that's the right answer. Good. No, but where are you stuck? You got it, but it's not. What do you mean by that? Solve it. Solve karo usko. Right. Right. Root 3 as 1.7. Substitute 1.7. You guys know the value of root 3, right? 1.7. Substitute. Hmm. Answer is 1.36 into 10 to the power 4. Anyone getting the same answer? No? Tell me what happened. It's not coming same. 1.36 into 10 to the power 4. Electric field is 5 into 10 to the power 5. Electric field. Then surface area pi r square. So 3.14 into r square. So what is r? 10 centimeters. So that will be how many meter? 10 to the power minus 1. 10 to the power minus 2. 10 into 10 to the power minus 2 or 10 to the power minus 1. So pi r square. Anything else missing? Cos 30. So cos 30 is how much? 1 by 2? 1.36. अच्छा ठीक है. Let's solve it. So 5 into 3.14 into root 3 by 2 into this becomes 10 to the power 3. So this will be 5 into 3.14 into 1.7 by 2 into 10 to the power 3. So multiply everything. It should come approximately 1.35 or 1.36 into 10 to the power 4. ठीक. How much you get? 1.4? It will not have major difference. It should be close to that. Because if you divide also 22 by 7, you will get 3.1 something. Answer will not have major difference. So you can just multiply everything, divide by 2, it should be close to 1.36, 1.37. Not coming? After multiplication also? Coming the same answer? Next question. So the question is, a cylinder is placed in a uniform electric field with its axis parallel to the field. Find the electric flux through the cylinder. Find the electric flux through the cylinder. So yeah, did you get the answer for the last question?
Yes, sir.
Advait, what about you?
Yes, sir.
So draw a cylinder first. We can solve this without uh, doing anything. You can tell the answer. What is the answer? E pi r square. That is not possible. Two times is possible, but how come only one time? What should be the answer? Cylinder. Okay. Draw the figure first. I know different answers will come. Draw the cylinder. If I tell the answer, you will do anything to prove the answer is zero. Okay. Now you will do anything to prove that it is zero. That's what I was telling. That after listening the answer, you will try your best. Before knowing the answer, vague answers will come, vague methods. Okay. I'll show why it is zero. Draw the figure. No, first I'm telling that draw the cylinder. The axis of the cylinder should be parallel to the electric field. Keep that in mind. Yes, he has drawn the correct figure. Draw. Show the electric field lines. Yes. It can be have they mentioned vertical or horizontal? You can draw vertical also as well as horizontal. Anything is fine. No need to draw coordinate axis here because no coordinates are given. So coordinate axis is not required. You just draw a cylinder where the axis of the cylinder is parallel to the electric field lines. And why I was telling that we don't have to use a pen or we don't have to write anything, just understand it. I will show the steps also. If it comes as a subjective question, how to approach it. But if this is an MCQ, we should be able to solve within 5-10 seconds. So I'm drawing horizontal cylinder. You can draw vertical also. Both are correct. Until and unless they mention, you can draw any configuration. Cylinder. So what will be the axis of cylinder? This will be the axis. So they are telling that electric field lines are parallel to the a cylinder is placed with its axis parallel to the field. Axis is parallel to the field. So this is the axis. So electric field line is in this direction. This is the electric field line. Now, all of you just observe one thing. I'll use my bottle to explain. Tick. Cylinder, horizontal. What type of surface it has? This is called area of cross section. Circle. So, what is the cross section of cylinder? Circle. Circle. This part is called what? Curve. This is called curved surface area. This is basically is called base or cross section. So, cross section is what? Circular. Here and here. So, electric field line is passing like this. Tick. Electric field line is passing like this. So for this top surface, where will be the area vector? Up. For this top surface, area vector will be up. And electric field line is like this. What is the angle? 90. What is cos 90? 0.
0.
So for the curved surface, what will be the flux? 0. Is the funda clear? Anyone having doubt? Curved surface के लिए electric flux will be 0 because angle will be 90. So when you solve it as a subjective question, you will write those steps. That for the curved surface, the angle between the area vector and field line is 90 degree, cos 90 is 0, so flux is 0. Now see for the area of cross section, I'll give time to copy, just give me one more minute to explain everything. If I take cross section, circle, circle, area vector is perpendicular and outward. Area vector for this will be in which direction? This. What is the angle between them? 0. Any problem? Electric field is there for this one. Area vector will be perpendicular and outward, not inward. Perpendicular and outward. So area vector will be this. What is the angle? See the angle? 180. All clear? Check. Now, the thing what we say, ki, sir, net flux. So because of curved, I'm not writing because of curve, I'm directly writing 0. 0. So what we say here, cos 0. So electric flux will be positive or negative? Positive. Cos 0 is 1. Cos 180 is minus. If I write the electric flux here, it will be E S cos 0. It will be what? E into S. And what is the area? Pi r square. For this one, cos 180 is minus 1. So I'm directly writing minus E pi r square. Any doubt? Now what should be the answer? 2 E pi r square or 0? Anyone for 2 E pi r square? Anyone? No one. No one is for E into 2 or 2 into E pi r square means twice. Both are in the opposite direction, right? So this minus of this, so minus minus will become plus. Huh? ठीक. So you feel that it should be 0. So listen to the statement what I'm making. This is towards which side? Right side. So net electric flux should be what? This minus of this. Minus minus should become what? Plus. So can it be 2 times of E pi r square? No, because electric flux is a scalar quantity. There is no direction. So we will just add the magnitude. So the minus what I have written here is not direction. This minus is telling that boss magnitude itself is negative because flux is not a vector quantity. Is the funda clear? So whenever you have scalar quantities, what do? You will not consider the direction. Whatever is the magnitude, add. So the mistake what few students do here, they say that what we do in vectors, that whatever is on this side minus whatever is on this side. So minus minus becomes plus. So that is applicable for vectors. You remember conservation of linear momentum? First wala question. MV minus of minus MV becomes 2 MV. Same mistake we end up doing here. So here you have to be careful. Since it is not a vector, you will not see the direction. Whatever is a magnitude, add both. Answer is 0. I got disconnected. Copy it. It's good that you're not feeling that it should be two even. Then problem is only over. Why are you thinking? They are two separate direction, na? ये left side पे और right side पे है. It is on the right side. This is on the left side. And flux doesn't have a direction. You are talking about which direction? Air, electric field उस direction में है, but area vector तो opposite है ना? That's what I'm trying to tell. There is no concept of direction in electric flux. You just see the magnitude, and how will the minus plus come according to the angle? Okay, minus plus will come according to the angle, not according to the direction. There is no concept of direction here. Then, any doubt? Yeah. So can we solve this without writing anything? The moment you imagine the figure, I think aram se you can manage. So in the exam, you have to mention, means draw the figure, and for this surface, you draw this thing like this. Take a small area. Area vector will be like this, ds or dA vector. So what is the angle? 90. You can show like this in the exam. Same thing you can show here also for bottom also. So this diagram is self-explanatory. I hope that your teachers will not cut marks for that, but you can still check with them. So this is self-explanatory that curved surface area will not contribute into the electric flux. Okay. Now let us modify this question. What modification we will do is, if the electric field lines are not parallel to the axis, the question is electric field lines are perpendicular to the axis. So you can add second part in this question, that electric field lines are perpendicular to the axis. If electric field line is perpendicular to the axis, this time which surface will participate? Curve. Opposite. Just previous to opposite. It's common sense. If I draw the figure again, if I draw the figure again, so this time I'm telling that electric field lines are perpendicular to the axis. This time electric field lines are perpendicular to the axis. So if you see, the area vector for this will be in this direction, and the area vector for the bottom curved surface will be in this direction. So the electric flux will be contributed by this one and this one. For the area of cross section, this is basically ds vector, and electric field is like this. So for the cross section, theta is 90. So the flux due to this will be 0. Same thing here. Theta 90. So flux due to this will be 0. And here what will happen? What is the angle in this case? 0. In this case, 180. So if the flux is phi e here, what will be the flux here? Minus phi e. So what will be the total? 0 plus 0 then this plus this is 0. Copy this quickly. Done? Any questions? All clear? Write down the heading. Gauss law or Gauss theorem. We'll just discuss the introduction part. One second, let me call it. Got disconnected. Anyone is RCB fan here? Huh? Saw yesterday's match. They got disconnected, but none of them told me also that I'm disconnected. This part all of you copied, no? Students attending online, did you guys miss anything? I got disconnected in between. Just check.
Sir, we missed it from the
Second
second
figure.
diagram.
Copy that. In the second diagram, I'll explain that what did I discuss? That if the electric field lines are perpendicular to the axis, that's it. If the
Okay,
electric
sir.
field lines are perpendicular to the axis. So this time curved surface will participate, and for the cross section area, it will be 0. So make a note of this quickly. We'll discuss the next thing. Who transferred that same thing? Right on. Did they fill the form? Huh. They transfer. Did they talk to Vikram? What question they had regarding something? क्या चाटने तुमसे क्या बात है क्या पूछ रहा था सब्जेक्ट डिटेल्स क्या कौन सा डिटेल सब्जेक्ट का ये क्या होता है मतलब कि बोर्ड का कैसे होगा एंट्रेंस का क्लास कैसे होगा वो सब सही है वो तो सब बता दी वर्षन में सब्जेक्ट कैसे देना अभी से नहीं चलेगा वो चट्टू कॉल की थी अभी हाँ तो तुमको नीट के लिए हमको कॉल किया क्लास में थी मेरे को भी की मैंने उठाया फिर दोबारा कॉल किया मैं उसको बोला कि अब एडमिशन फी पे कर दीजिए फटाफट तो बोले आई विल ट्रांसफर बोली मेरे हस्बैंड को बात करना है विक्रम सर से तो आई बात कर मेरे से बात करके वही तो ये तुमसे बात करने आया था ना उस दिन ये 10 मिनट बात करती थी इसका हस्बैंड बाहर था किसी बात फिर आया सेम क्वेश्चन वही पूछा फिर चले गया फिर वही पूछा इतना पहुंच ही नहीं पाएगा महीना ही नहीं 9 ही महीना है महीना तो 9 है बस मार्च का कहाँ 11th का 12th का बट 11th कैसे लोगे मंथली मंथली? 11th कैसे लोगे? 11th तो 9 महीना है। अप्रैल मई जून जुलाई अगस्त सितंबर अक्टूबर नवंबर दिसंबर। ये 12th के लिए आया था। 11th में कैसे करोगे सोच? हो सकता है उसको बोलती है कि उसे को डिवाइड ये जो है वो डिवाइड कर हुआ है। Gauss law or Gauss theorem, whatever you want to say. I think law is the correct statement. Gauss law. So, have you guys heard of Gauss before? No? Grade 10, all of you have heard. No? He was a very famous mathematician also. Didn't hear the story? Grade third or fourth child seeing out a window. Maths teacher gives the punishment. Add 1 to 100. That student tells the answer within 30 seconds. Teacher thought that he is using calculator, but he was born genius. What did he do? He just reversed the series, added. So he got 101 100 times. So he told that 10100. Didn't he? Didn't you hear this story? You guys know this or not? If I ask you to add from 1 to 100, you just have to do this thing. This thing we have done in the class. You guys don't remember? In AGP, in sequence and series, shifting the term. So if I have to add from 1 to 100, now you know the formula. Sum of first n natural number is n into n plus 1 by 2. But you can't expect a third grade student to know this. So what he did, he reversed it. If you reverse, will the sum change? But what will change? See here. Add. What will you get? S plus S, 2S. And every sum is how much? 101. How many times? 100 times. So what is the answer? S equal to 101 into 50. Okay. So Gauss was a very famous mathematician also and physicist both. Okay. So what did Gauss tell? That if we have a closed surface of any shape, any random, it should not be a standard shape. Standard in the sense, it's not necessary that it has to be a sphere. It's not necessary that it has to be a cube, cuboid, or cylinder. It can be a closed surface, but it has to be closed of any shape. So if you take a random shape ka closed surface and I keep a charge q1 inside it, random shape, and I kept a charge q1 inside, the total electric flux passing through this closed surface will be charge inside the surface divided by epsilon naught. This is the statement given by Gauss. Gauss tells for any closed surface, the electric flux passing through this surface should be charge enclosed, means charge inside, divided by permittivity of the medium. Permittivity of the medium. So here what medium is there? Vacuum. So epsilon. You can write down the Gauss theorem for any closed surface. For any closed surface, the total electric flux passing through the surface, passing through the closed surface is equal to 1 by epsilon naught times the charge enclosed in the surface. Written? Now let's take an example. Q1 minus Q2, Q3, Q4. Find the electric flux passing through this closed surface. Question is, find the electric flux passing through this closed surface. Use the statement. What is the charge enclosed? Q1 plus Q3 minus Q2. Q4 is enclosed or outside? So this will participate in the flux? No, that's what the statement is telling. That according to the Gauss law, the net electric flux passing through a closed surface is charge enclosed by epsilon naught. Whatever charge is outside, I'm not bothered about that. So the net electric flux will be charge enclosed Q1 minus Q2 plus Q3 divided by epsilon naught. The charge which is outside this Q4 will not participate in the electric flux passing through the surface. Okay. Now, one more statement in this. If I write electric flux, what is the first definition you studied for electric flux in terms of integration? E dot ds. Okay. And this is equal to what? Charge enclosed by epsilon naught. So this is basically the charge present inside the surface. Now, question what they ask. Question is, this electric field is due to all the charges or due to the charge is only inside? So the answer is this electric field is the net electric field due to all the charges, whether it is the charge outside or inside. Okay. So the statement is this electric field, which is used in the formula for electric flux, is due to all the charges which is inside the surface as well as surrounding the surface. So make a note of that statement. This electric field is due to the charges inside and outside as well. The electric field is due to the charges inside and outside as well. So in this case, this electric field is due to Q1 minus Q2, Q3 as well as Q4 also. All clear? Any doubts? Now the last statement in this, after that we'll discuss, we'll stop till Gauss law, we'll not discuss further. We'll solve some numericals from electric field. The statement is, here things are present inside the vacuum or air. So you are using the permittivity of that medium. If I change to some other medium, what will happen? Will the charge change? No. What will change? Permittivity. Okay, permittivity. If I say that this is any medium other than vacuum or air, so here you will use the permittivity of that medium. So make a note of that. If medium changes, so what will be the change in this formula? We will write the permittivity of that medium. Good. Should we discuss the next thing? Any doubt in Gauss law or how to apply it? Just focus on the charge enclosed. You should not bother about charge which is outside. But the point which you need to keep in mind that this electric field is due to all charges. Next thing what we need to discuss that if medium changes, the permittivity will change correspondingly. Then Gauss law is applicable for all type of closed surface, but it has to be closed. The moment surface is open or the charge is kept in open, you can't apply Gauss law. Suppose just see this thing here. This is a question in your NCRT also. I'll give that as homework. If this is a surface, rectangular plate, I keep a charge here. So is the charge enclosed? No, it's in open. The charge is in open. So can I apply Gauss law on this charge? No. If they ask you, tell me what is the electric flux due to this charge, you cannot apply Gauss law because this charge is not enclosed by a surface. So what we will do, we will draw a surface. The surface is not present, so I will draw a surface, and that surface is called Gaussian surface. Okay? So we will see few questions where we will draw the surface because it is absent. And the reason for drawing the surface will be so that I can apply Gauss law. And what is the advantage of applying Gauss law? Gauss law is a simple method for calculating electric flux. Don't just read the law, first understand that what is the advantage. See the formula. What is the formula? Charge by epsilon naught. What do you need? It is the simplest method for finding the electric flux. Okay? So if the base is square, let's assume that if the base is square and you want to enclose the charge, what type of surface will you draw around the charge? Cube. Cube. Okay? If it is rectangle, then you will think of cuboid. We'll discuss that in the next class. But are you guys getting the idea? Okay. So let's discuss few questions. We have 30 minutes. We'll solve some good questions. I've selected few conceptual problems where mechanics in the sense basics of grade 11 physics is included with electric charge and field. The first question is a pendulum of mass 80 milligram carrying a charge of 2 into 10 to the power minus 8 coulombs is at rest in a horizontal uniform electric field of 2 into 10 to the power 4. So you need to find the tension in the thread. Find the tension in the thread of the pendulum and the angle it makes with vertical. This is the question. What is this? So all of you draw the figure first. So this is the pendulum is at rest in a horizontal electric field. So electric field is in the horizontal direction. So what will happen to this pendulum? This pendulum has a positive charge. All of you see on the board. This pendulum has a positive charge, and the electric field is moving like this. What will electric field do on this charge? Apply a force. Charge is positive. Okay. Electric field is in this direction. So force will be also in same
Same
direction.
direction.
Any problem? Now you will say, sir, where is the direction of electric field given? It is not given. If you want to assume, you assume this direction. If you assume this direction, electric field is towards left, charge is positive. So force and electric field will be in the same direction. So force will be in this direction. So what will happen to this thread? It will start moving like this. Correct or not? It will start tending to move in what? A circular arc. Are you guys able to visualize? So I will draw the electric field in this direction. This is electric field. So this is a positive charge, so it will experience a force and the pendulum will move like this. If any questions are there, clarify. If no, very good. We'll move ahead. So find the tension in the thread of the pendulum. Is the mass given? Yes, mass is given, charge is given, electric field is given. So what will be the force acting on this? In the downward direction, mg. Horizontal direction, QE. That's what we discussed now, right? In the horizontal direction, this electric field will push it with what force? F is equal to QE. We discussed yesterday. What is the force in the string? T. Tension is always a pulling force. Tension always acts away from the object. So now you will take two components. We'll take two components. So if I take this angle as theta, what will be this angle? Theta, alternate interior angle. So this component will be T cos theta. This component will be T sin theta. Any problem? Check and let me know. Don't think that these questions are difficult or not in our syllabus. These kind of questions are asked. So T sin theta, T cos theta. Now, if it is in equilibrium, if it is in equilibrium or at this angle, they're asking this angle, right? At this angle, upward force should balance downward force. Right ka force should be balanced by left ka force. What will I write? T cos theta equal to mg. T sin theta equals to QE. If I divide both. So second by first, sin theta by cos theta, tan theta. So tan theta will be equal to what? QE by mg. So theta will be equal to how much? Tan inverse of QE by mg. All clear? Calculation I am leaving on you. What calculation? Charge is given, you will substitute. Electric field is given, you will substitute. G, you know it is what? Mass is 80 milligrams. 80 milligrams will be how many kgs? 80 into 10 to the power minus 6. It is not grams, it is milligrams. So milligram to kg will be how much? 80 into 10 to the power minus 6. First milligram to gram, 10 to the power minus 3. Then gram to kg, 10 to the power minus 6. So I'm not doing the calculation. You guys can manage, right? Multiplication, division. I'm leaving that part for you. But make sure that mass is in milligrams. So 80 into 10 to the power minus 6 kg. Asking 90 minus theta. Vertical, no? Angle with the vertical. Angle with the vertical. I assume this to be theta. And once you get theta, right, you can substitute in any equation, either first or second, you will get what? Tension. Okay, which you should not take. So substitute theta here, either in the first one or second one, you will get T. Clear? Any problem, students? This is a moderate level question, nothing difficult. Maybe you are seeing what you used to see in grade 11, the same thing. So what I told that I have taken few questions where free body diagram equations of motion will be combined with electric charge and field. So whatever theta you get from here, that theta you have to substitute either in first equation or second equation. So the only unknown will be t. So you can get t. Okay. Okay. Let's move to the next question. I think it will not be a standard angle. What I think when you solve it, you will not get a standard angle.
So it's tan inverse of 5.
Yeah, that's what it will not be a standard angle. You don't have to worry about that. You can leave it. Should I give the next problem? You guys can leave 3-4 lines and calculate it. I'm telling that it will not come as standard angle. You can use calculator. I think it should come somewhere close to 26 or 27 degrees. It is not a standard angle. You know that. Okay. So you can do that after the class. Leave 3-4 lines. But is the method clear to everyone? Whatever theta you get from here, substitute in any equation, you'll get tension. Next question. Stop talking. See on the board. So we have two plates. One is positively charged and other is negatively charged. We have two plates positively charged and negatively charged. So what will be the direction of electric field? Down or up? Down. Huh? Down. Okay. Electric field lines diverge from positive and converge on negative. Yesterday we discussed that in the electric field lines start from positive, terminate on negative. So in this case, the field, so doubt. Okay, so you can ask the confusion here. No? Whatever confusion you have, I am here to explain everything. So electric field lines will be from positive to negative. So sometimes they may not draw, so you should be knowing that what should be the direction of electric field. Okay. Now the question what they're asking, there is an electron. The electron is entering into this region like this. So the initial velocity of this electron is along x-axis or horizontal velocity. If you see, the moment it is about to enter, the initial velocity is in which direction? Horizontal. Or you can say x. If I take this as x and this as y, initial velocity of the electron is in x direction. So before we start solving question, let's analyze few things. Electron enters, and if you forget physics, if you use your common sense and think that there is something which is pushing the electron continuously, right? Forget about electron. Suppose any ball has been thrown in this region. So when ball enters into this in the horizontal direction, this electric field will do what? Push it. So this electron will start or ball will start coming what? Down, like a parabolic path, like a projectile, like a projectile. If you remember horizontal projectile, we discussed in the class. If an object is launched like this, what happens to it? Slowly, slowly it start coming like this. Why? Because of gravity. Initial velocity is in horizontal direction, but gravity will slowly, slowly push it and it will fall like this. Okay. But there is a catch here. If you remember the statement, if charge is positive, then the direction of force and electric field is same. What charge is here? Negative. So direction of force and direction of electric field will be opposite. Electric field is in down direction, so force should be up. So electron will move down or up? Up. 50% of the question is solved. They sometimes ask you that if an electron enters a uniform electric field, what will be the trajectory? Option, straight line. Second option, ellipse. Third option, upward parabola. Fourth option, downward parabola. So here when it moves, force ka direction electric field ka will be opposite. So answer will be upward parabola. Concept clear? What is the trajectory? The question is, what will be the trajectory of this electron when it leaves this electric field? Question is, what will be the trajectory of the electron when it leaves the electric field? All clear? Aditya, no doubts? Noted? Pranav, Tanuj, Dia, any doubts? This will be the trajectory. Are you guys clear? Why upward? Anybody who needs the explanation again? So force on the electron will be in the opposite direction of electric field. So force will be continuously upwards. So it's like someone is pushing this electron continuously in the upward direction. It will have a upward parabola trajectory. So that was the first part of the question, that explain what is the trajectory. Now suppose if I replace this electron with a helium particle. Helium is positive or negative? Positive. Helium is positive. So helium will have which trajectory? Downward. Downward. So you want to note down, you can make a note of that. Okay. Write your notes properly. I'm again telling you guys. If your notes are written properly in the last 3-4 months, you will be very much relaxed. That you have everything written at one place. You don't have to open different books. The moment you read your notes, you feel that I know everything. That confidence needs to be there. Otherwise, what happens? You write 50%, 50%, you start searching here and there, and no one will give them your notes in the last 2-3 months. And don't ask me notes. I will not give whatever I'm giving in the class. That's why I'm telling you, write. I want you guys to write everything. Don't be lazy, at least in grade 12. 1 year is there, give your best. Everything will be best. Sure, let's discuss the next thing. So, what is the question? I've not written the second part. So, the question is asking the velocity is given. If the initial velocity is v naught, it is entering into this electric field with velocity v naught. So, the question is, and the length of the plate is also given L. So, question is find the angle of deviation of the path of electron as it comes out of the field. Electric field का strength is E, length is L, initial velocity V naught. Okay. I want you guys to try this. If you are still thinking what is theta here, when it comes out, draw the horizontal line. This angle has been asked. These things are not mentioned in the question. You have to think the moment it leaves, what is the angle of deviation? You will measure the angle of deviation with what? Horizontal line, right? Because initial direction of motion was what? Horizontal. What is tan theta? Perpendicular by base. Perpendicular by base. So here we will talk in terms of what? Perpendicular component of velocity divided by horizontal component of velocity. So we will find tan theta in terms of perpendicular component of velocity by horizontal component of velocity. Okay. Do you know where was this question asked? Your board exam. And in which board exam? Supplementary exam. You guys know what is supplementary? If you fail the re-exam. So this question came in the re-exam, not the normal board exam. Okay. So your board exam ka level is not simple. I told you this time physics paper was tougher than JE paper, the board paper. Have you guys seen, heard, means talk to your seniors? What did they say? JE paper was easier than board. Okay, when I also saw the paper, I was shocked that they made the paper to fail students. 80% of the students will fail if they don't give grace marking. There were only one question directly from your NCRT, that also of 2 marks. Okay, so physics and maths ka level of your board exam is not easy. So if someone comes and tell you that why are you solving NCRT, ignore them. First textbook yesterday also I told, finish NCRT line by line, examples as well as exercise. After that, you're free to solve any book, whatever you want, but never ignore NCRT. But in the notes, I'm covering everything. You don't have to worry. Okay. So I need to find this thing. So I will write Vy by Vx. So what is Vy? The moment it comes out, the velocity in y direction. What is Vx? The moment it comes out, what is the velocity in x direction? Is the funda clear? What is Vy, Vx? Now, all of you just answer this simple question. If you remember projectile motion, the thing what I'm going to explain will be very simple for you. If you know, don't know also, it's fine. Any external force in the horizontal direction or any force in the horizontal direction on this charge. See the diagram. Any force is there in the horizontal direction? No. Which force is there? Nothing. It has a velocity in the horizontal direction. There is no force acting in the horizontal direction. But which force is in the vertical direction? F equals to QE. Now, if you're thinking of gravity, sir, where is gravity? If you remember, we discussed in one problem that electric force is way higher than gravitational force. So if you're talking about electric field, in that region, you can ignore gravity. Gravity is there. I'm not telling gravity is not there, but gravity ka influence in front of electric field ka influence is negligible. So don't start thinking, sir, where is gravity? Why only electric field? Why not gravitational field? Because the effect of gravitational field will be negligible here. So we are ignoring. Clear? So in the horizontal direction, there is no force. Will the velocity change? No. What will be Vx? Same as V naught. If you remember at least the basics of projectile, same statement was there. In a projectile motion, the x component of velocity remains constant. Y component changes. Same thing here. So what will be Vx? Vx will be same as V naught since there is no external force in x direction. So no external force or no force, it means velocity should remain constant with time. Now Vy, what will I write? Which equation of motion? First, V equal to u plus at. Correct? So Vy will be what? Uy plus ay into t. Correct? So ui means what? Initial velocity in y direction. What is the initial velocity in y direction? Zero, nothing.
Zero.
Initially, it has velocity only in x direction. So what is ui? Zero. Now, what is the acceleration in y direction? G. What is the acceleration in y direction? G. Force by mass. Force by mass. So force by mass. Who is applying force? Electric field. So what will be force? Q into
QE.
E. QE by M. And what is the charge? Electron. So E, capital E by M. See the beauty of this question. You can't solve this like what I tell that solve without writing. These are the questions which takes effort, which connects mechanics. Okay. And do practice. Don't solve easy questions. Nothing will happen if you solve easy question. Nothing. You will never grow. Don't just think I need marks. If you're growing, if your intelligence level is increasing, you will get marks. Who will stop you from getting marks? It's not that everyone outside is there to stop you. Put your effort and solve these kind of questions. Okay, still thing is left. What is that time? How will you find time?
Distance by speed.
Distance by speed. What is the distance? L. What is the speed? V naught. So T will be equal to how much? L by V naught. Is it clear? Put the value. L by V. Today is Holi. Huh, Saket? We also have tomorrow. Rain dance is there in our place. It's there. You already went. It's tomorrow, right? Yeah, I'm asking in Prestige. It's on. Achha. Why will I talk about some other place? You stay in PT, right? That's why. Okay, so E by M into L by V naught. So this is the velocity in y direction. Any problem? All clear? So we can ask this as a paragraph based question also. Okay. Paragraph. First find the acceleration. Find the final velocity in x direction. Find the final velocity in y direction. Then find theta. So what will be tan theta? E by M L by V naught divided by V naught. So this will be equal to EL divided by M into V naught square. So this is tan theta. Mark this question as important. Do practice this after the class also 1 or 2 times. Clear? Any problem? One last thing. What is the final velocity? What is the final velocity? When you have a component in x direction and y direction, how do you find the resultant velocity? Under root of Vx square plus Vy square. Vx and Vy are perpendicular to each other. What will be the angle between them? Cos 90. So if you're thinking that why you're not writing the third component, which is Vx square plus Vy square plus what? 2 Vx Vy cos theta. So what is theta here? 90. So that will be 0. So don't ask me to substitute and solve. I will not do that. Okay. You can do it after the class. So you can see the whole solution. If anything you guys want to clarify, you can let me. I'll explain anything. I'll explain again. No? All clear? Okay. We will keep the class till here. Now we can take a 5 minutes break, then I will give the paper. We'll start the exam in 5 minutes. Students attending online, I'll send the paper in the group. You have to keep your webcam on and you can write the exam.
Okay, sir.
We'll start after 5 minutes. But at least come for offline on the exam day because I'm going to stop this online exam thing. Exam will be only offline.